Hi learners, welcome to my YouTube channel. So today let us see the part 7 of the same topic, that is the square and the square roots. So in this one we will see the exercise, that is the 3G. So the first problem here, we have to evaluate root of 16 by 81. So this also is a perfect square and this also is a perfect square. So 16 can be written as 4 into 4, 4 4s are 16, and this is going to be 9 into 9. So here this is going to be, when you take it outside, we can make it separately. The numerator and the denominator will separate it. So this is going to be when you take root and when you have two the same numbers, that is going to be 4, means the square root of 4 into 4, that is going to be 4. And here this is going to be 9. So the answer is 4 by 9. Again, now here you can see this also is a perfect square and this also is a perfect square. So here this will be 8 into 8, and this is going to be 15 times 15. So you have to see that you know the squares of at least till 20. So then it is easier. Otherwise, if you don't know, so now what you can do here, 225, you can take the factors of this one. So now 3 7s are and 3 5s are, 3 2s are, and here 5. Here 5 and 5, 5 1s are. So now what you can see, they are in pairs. Now this 3 and 3 here, and this 5 and 5. So you will take from here one only ones, and here you will take from only ones, because square roots means you will just take one. When it is cube root means from 3 you are going to take one. So this will be 3 times, this will be 15. So this is 15 into 15. So now you can separate the roots. The numerator will be separated and the denominator here. So this is going to be 8 by 15. Now let us see the next one. 121. So that is for 11 into 11. And 256 will be 16 into 16. So again, if you don't know the perfect squares, means you are going to use with the help of the factorization. It's better to learn. So here 11 into 11. So here will be 16 into 16. So this is going to be 11 by 16. So now again, this is the perfect square. This also is a perfect square. So this will be root of here 25 into 25. And this is for here will be, let us see, 729. See here, I will show you how it is 625 also. So now this goes with 5. So we can see here we'll make pairs. So this is going to be 5 and 5. So this is going to be 25. Now let us see for 729 as well. So 3 goes with 3. Again this goes with 3. So what you can see, how many 3s we can make pairs of this one? 3, 3, and this will be 3. So it is going to be 3 3s are 9, 9 3s are 27. So you can also write here 3, we can write 6 times here. So you can do the factorization over here. So now this is going to be, we can separate the numerator and the denominators, the root of that. So this is going to be 25 divided by this will be, when you group it. So this is going to be, this will be 3, this will be 3, and this is going to be 3. That is going to be 27. So the next one, now this is in a mixed fraction. So now let us make it to improper first. So you know, whenever there is a mixed fraction, 3 integers 13 by 36. So what will you do here? You will multiply this and this one. So 36 into 3. So this is going to be 108. So for that 108, you are going to add this one 13. So 108 plus 13, this is going to be 121. So this one we can write now directly as 121, and the denominator is going to be the same. So divided by 36. So now what you can see, this both are the perfect squares. So this will be, you are going to write for this one as 11 into 11 is 121, and here will be 6 into 6. So now you are going to separate the numerator and denominators. So that is going to be 11 by 6. So now next one, and this also now, see here, one thing you can do here now, 11 by 6, this is a improper fraction. So what you will do, 6 ones are 6, so that is going to be 5. So what will be that? 1 integer 5 by 6. So you are going to write the answer 1 integer 5 by 6. So now look at here, the sixth one. Again, what are you going to do? You are going to multiply this. Now let me write separately over here. So you are going to multiply this into this. That will be 324 into 4. This you are going to multiply. So this will be 1296. And 1296 you are going to add to this one, to this number. So 1296 and 73. So that is going to be 1369. So now what will you do here? You will write here 1369 divided by this number, that is 324. Now see here, because this is a big number directly, it's not easy to do. Now let me do here. 1369, we'll take the factors of that, the help of the prime factorization. So now this is going to be, this is not possible with 2, so we'll go with 3. Again, 3 is not possible. Then we'll go with 4. 3 fours are, this is not possible with 4. Again 5, not possible. 6, 7. So this is only possible with, now see here, 1369. I'll show you the other method for this one, because this is going to be a big number. So now see here, when you have 10 square, that is 100. 20 square, that is going to be 400. 30 square, because 2 square is going to be 4. So 30 square is going to be 900. And 40 square is going to be what? 4 4s are 16, that is going to be 1600. So now can you see this 1369, it comes in between 900 and 1600. So now what are you going to do here? So now the last digit of this one, the unit place is 9. So because that will be definitely not 40, so it will be somewhere in 30s. So 30s means, where do we get 9 over there? It will be somewhere 33, or it can be 37. So when you do 33 into 33, and you will look for 37 into 37. So this is going to be 99, and this also 99. So this is not possible. So now let us see for this one, 4, that will be 25, and this again here. So 1369. So here, now you got it. So this will be 37 into 37. So now again you will look for now for 324, you can find out the factors of 324 easily. So 324, because this is a smaller number. So now look at here, 2, it goes with 2 because this is a unit place is even number. So here 2 8s are. Now this will go with 3. So how many 2s we have? 2, and 3s we have 4. So we are going to write here. So what is that going to be? You will write here root of 37 into 37 divided by root of So now what is that going to be? This will be 37 divided by, we'll make a pair. So this will be 2, this will be 3, and this is going to be 3. So 3 2s are 6, 6 3s are 18. So here will be 18. So now you can see this is an improper one. So you will write here 37 divided by 18. 18 2s are 36. This is 1, 2 integer 1 by 18. So it is going to be 2 integer 1 by 18 is the answer. Now again, now let us look for this one. So we'll write here 3 integers 33 by 289. We are going to multiply this into this. So this will be 867. 867, you will add 30, this one to it. So this is going to be 900. So now let us write here 900 divided by, this is the denominator, 289. And now you know 900 means that is going to be 30 into 30. Or you can also write this one as 900. Now because we have to, so directly also we can write here, or you can find out the factors with it. So you know 30 into 30 is 900. So you can write here 30. So first thing you will do one thing. First we'll separate the squares, the numerator and the denominators, and then we can write here. So that will be more better. And now you know that is 289. When you take the factors of this 289, so it is going to be, and instead of doing that, because here see, we can till 20, we can do it easily. So that is going to be 17, because this is 9. 17, let us see, 17 into 17. So that is 289. So we can write here 17. So now again, this is an improper one. So we will make it to mix. So 17 ones are 17. And this is going to be 13. So 1 integer 13 by 17. So this is going to be 1 integer 13 by 17. So now this is a different way, because now we can see here that both of them, these are not the perfect squares. So first thing what we can see, we can simplify that one. So for, we will do one thing, because the root is separate. So now let us make the root together. So now we can do one thing, we can find the HCF of that. So HCF of 80, and this will be 405. So now let us do it. So this will be 240s are, 220s are, 210s are, 25s are, and 5 ones are. So for 80, what do we get? 4 2s and this one. And now let us see for this one. So this will go with 3. 3 ones are, then 3 3s are 9, and 3 5s are 15. Again, this should go with 3. Again, this should go with 3. Now 3, and this will be 5. So now what will we get here? We can write here 405 is equal to, these are all the factors of it. So how many 3s do we have? There are 4 3s. And 1 5. So whenever we take the HCF means we take only, HCF means only the common ones. So now only the common here is 5. So what are we going to do here? Here we'll do one thing, we are going to divide it by 5. So when you take the HCF, it will be a perfect one. So instead of doing the simplification orally, so HCF works here. So this is going to be 16 divided by, this will be 81. So now you can see these both are the perfect squares. So now you can separate it. So that will be the numerator and the denominator. We'll write it separately along with the root. So this is going to be root of 16 is going to be 4, and root of 81 is going to be 9. So the answer is 4 by 9. Now again this we are going to do the same thing. We are going to take the HCF of this one. So now let us take for 1183 and 2023. So now this is possible, this is not possible with 2. So now let us see for 3. 3 should be, it is a 9 and 2, so 27. So this is also not possible with 3. Then whenever you have 3 at the last means not possible with 4, 5. Then we can go with 7. 7 ones are 7. So here will be 7 6 are 42. 7 9 are 63. Again this should go with 7. 7 2s are 14. This will be no, this doesn't go with 7. 7 2s are 14 and this will be 29. So it should go with 13. That's not possible with 7. So now this will go with 13. So 13 ones are 13 and this will be 3 remains, 13 threes are 39 and 13 ones are 13. So now again now let us look for the next number. This also doesn't go with 3. So now let us see whether this goes with 7. So if you want we can do it separately. 2023 with 7. 7 2s are 14. 62. 7 8s are 56. And this is going to be 63. 7 9s are 63. So 289. So it goes with 7 and here will be 289. So now again this should go with, this is not possible with 7. Then if we go for 13. So you know this will be with 17. 17 into 17 is going to be 289, because now look here, 17 into 17. This will be 289, and then again we can write here 17 ones are 17. So now how are you going to take the HCF? HCF means now 1183. This is 7 into whatever the factors we got over here. 7 into 13 into 13. And this 2023 is 7 into 17 into 17. So now we can see the common is just 7. So the HCF of this is 7. So now let us divide this one. So we can write this one as 1183 divided by 2023. We'll take a common root. So now this should be divided by 7. And this also should be divided by 7. So now what do you get after dividing by 7? So now let us see what do we get it, and this can be written as, so when we divide this by 7, now let me do it roughly over here, 1183 divided by 7, so 7 ones are 7, 48, so 7 6 are 42, and this is going to be 63, so 7 9s are 63, so we get 169. So here I'll write a 169 over here. And here will be, see, when we did 7 into this 17, that was 289. So we can write it directly 289, or you can divide and see later. So this will be, we can write a 169 divided by root of 289. So this should be written directly, this will be root of 169 is 13 and root of 289 is 17. So the answer is 13 by 17. So now look for this one. Again, now this is not possible. These are not a perfect square. So what will you do? We will write here together 98 into 162. So when we can do one thing for 98, we'll take the factors of 98. So that is going to be 249s are. Then this is only possible with 7. So for 162, we'll take 2 8s are, then 3 27s are, then 3 9s are, 3 3s are, and 3 1s are. So what we can do here, we can write for 98, we can write here, these are the factors for 98 and these are the factors of 162. So we can write that over here, 7 into 7, and this will write here 2 into 3 4 times. So now what we can do, we can take the pairs together. For that one, we can take this 2 and 2 together, 7 and 7 together, 3 and 3 together, because we want a pairs. So now we'll take here, same thing, just we are going to rearrange it. So it is easy to find a perfect square. Now what we can do, we can make the pairs. So we can put a, if you want, we can put directly the line over here. So these are the pairs. So now we are going to write it only once. So that will be 2 into 7 into 3 into 3. So that is going to be what? 14. 14 these are 42, and 42, that is going to be 3s are, that is going to be 126. So the answer is 126. So now let us see the next exercise. They are the objective types. So now here we have to take the correct answer in each of the following. Which of the following numbers is not a perfect square? So you know now this one, wherever now to make it to perfect square means we know the number ending with 2, 3, 7 and 8. They are never the perfect square. So here, can you see here? Anywhere this is by 6, this doesn't match. So here we can see this is 8. So this is not a perfect square. So we can say 5, 4, 7, 8 is not a perfect square. So you can put a tick over here. Again the same one, 2, 3, 7, 8. Now let us look for the one here. So here we can see the last number here. That is, here is 2. The ending number is 2. So that is not a perfect square. So now in the third one, 2, 3, right? So here, the ending number is 3 over here. So now in the fourth one, so here, the B1. Now in the fifth one, so here we can see the ending numbers are zeros. Can you see the ending numbers are zeros? So now, which if the ending number has zeros means it has a, if it is, which is not a perfect square, if it has odd number of zeros at its end. So here there are 2. So here there are 3 number of zeros. So these are the odd number of zeros. So this is not a perfect square. So these are the perfect squares. But here we have 3 number of zeros, means whenever the ending number are zeros. So if it has the odd number of zeros, so that is not a perfect square. So here this will be C. Now which of the following cannot be the unique digit of a perfect square? So here what we can do, the number 8. If it has the number 8 at the end, so it cannot be a perfect square. So this is the answer, the D1. The square of a proper fraction is, actually it is always smaller than the fraction. So the option is B. Now here, if n is odd, then 1 plus 3 plus 5 plus 7 to n terms is equal to, this is going to be, if it is odd, it is going to be equal to n square. Now which of the following is a Pythagorean triplet? So now for the Pythagorean triplet, you know, for every natural number that whenever the m is greater than 1, so you should have that 2m for the Pythagorean triplet, 2m, m square minus 1 and m square plus 1. So now consider the first number, we can consider this, that is 2m is, now we are, suppose we take A as the option. So this we are going to consider 2m as 2. So m is going to be 2 divided by 2, that is going to be 1. So now this one, now what is the other one? That is m square minus 1. So if we are taking m square minus 1, so in place of this one, we are going to put 1 square minus 1 because m is 1. So this is going to be 1 minus 1, that is 0. So here we don't have 0 over here. So this cannot be a Pythagorean triplet. Now let us see for this one. If we take here 2m is 5. So m is going to be what? 5 by 2. And the second one, what is the option here? M square minus 1. So if we put here 5 square by 2 minus 1. So this when you take, this is going to be 25 by 4 minus 1. So 25 by 4 minus 1 means the LCM is going to be 4. So this will be 25 minus 4, that is going to be 21 by 4. So this is not 21 by 4. So this cannot be the option. Now again here you will take for this one, if you consider this option. So here 2m is going to be 6. So m is going to be 6 divided by 2, that is going to be 3. So now we have m square minus 1. So m square minus 1 means you are going to write here m we got as 3. So 3 square minus 1, so that will be 9 minus 1, that is 8. So here we don't have 8. So this cannot be the option. Now, not because now this is the last one. Now let us see by the rule of the Pythagorean triplet. Now again here, now this is 8. So we're going to consider 2m is 8. So m is going to be 8 by 2. That is going to be 8 divided by, this is going to be 4. Now m square minus 1. So m is 4 means we are going to put 4 square minus 1. So this is going to be 16 minus 1. 16 minus 1 means it is going to be 15. So this satisfies. And the other one is m square plus 1. So m square plus 1 means 4. 4 square plus 1. So that is 16 plus 1, that is 17. So 17 is over here. So this is the correct option. So now what least number must be subtracted from 176 to make it a perfect square? So now for this one, to make it a, we have to go with the long division method. So now you can write it here. So now what will you do here? 170 means we are going to make a pairs first. So the long division means 2. This is 2 and this is going to be 1. So now we are going to look at here. So here 1 ones is 1. So now what are you going to do? You are going to add this one. We have done in the previous one. So 1 plus 1 is going to be here 2. And this will be, because 1 minus 1 is 0. So this we are going to take 76, because always in pair you are going to take it down. So now what you are going to do? You are going to look at this one. This is the unit place. So what should be the number over here? The possibility of getting 6 means it can be only here 2 2s are 4, then 3 3s are 9, 4 4s are 16. So here will be 24 into 4. So that is going to be here here 9. So that is not possible because this is a bigger number. So now what will you get here? 23 into 3. If we take here, this is going to be 69. So this is going to work because this is 76. Because if we take 24, that is not going to work. So here you will write here 3 and this is going to be 69. And when we subtract this, you are going to get 7. So now what is that? Remainder is 7. So now what will you do? What did they say? What least number one will be subtracted from 176? So we can say therefore 7 must be subtracted. So the next year, they said what least number must be added to 526 to make it a perfect square. So now again here we will do here 526. This is going to be, we are going to consider this one number, that will be 2 2s are 4. So this will be 1. Now we are going to add this one. So this is going to be 4. Now because this is a 4 is a bigger number, so you will take this 26 over down. So now what will you write here? Again, now let us see if we are taking 42 into 2, so this is going to be 84 because we want 126 here. 43 into 3, so that is going to be 129. So now if we are writing here 3, so if we write here 43 threes are, that will be 129. So if we write here 3, so minus 129, so this is going to be minus 3. So what are you going to get here? So from this one, what should be added to 526? So if you add 3 to that, because it is minus here, so now what will you write here? So here when you add here 529, because if you're adding 3 to it, minus this 526 is going to be 3. So least number should be, whatever you're going to add is, it is going to be 3. So therefore, least number to be added is 3. So the next one, what least number must be added to 1537 to make it a perfect square? So this is also the same type. You can do it with this one with the help of the same type, only the number is different, with the help of the long division, and you can try. So the next one now here is the 13th one. So now here they said root of 0.9. So here root of 0.9. So this is going to be 0.9. You can write here 0.9000. So you cannot do it directly because now we have to do with the long division. So now what will you write here? 0 is here, so you will write here 0 point. So now we are going to consider this 2. So 9 nines are 81. So this is going to be 9. So this is going to be 9 plus 9 is going to be 18 over here. So now you will put here 2 zeros because that is smaller one. So 180, if we take 184 into 4, this is going to be 32, 33. So this is going to be 736. So this is going to be 736 because if you take 785, then that is going to be a big number. So when you subtract this one, so what do we get here? We get here 164. So here you have to write 4 over here. So because the 4 was left, because we multiplied this by 4. So what do you get here? 0.94. So now here you can write the option is 0.94 because you cannot do it directly. Now again for root of 0.1. So 0.1 can be written as, we can also write that as 1, because root of that is going to be 1, and we are going to put here. So now what will you get here? We are going to make the groups. So now because it was 0.1, so that we can write here, we will start with 0. So 3 3s are 9. So again here, this is going to be 6, 0. So 61 into 1, that is going to be 61, because if we do 62 into that is going to be a bigger number. So here 161 ones are 61. So here will be again 9 3. Here will be 62. So you are going to put here 2 zeros. So 62, and if we are putting here 6, so it is going to be 3756. If you are putting here 7, it is going to be a bigger number. So here 6 and here 6, and then you will get here 3756. So when you subtract this one, you get here 144. So now, what is the answer? 0.316. So, which is the correct option? 0.316. So, the answer is the C1. Now, let us see for this one. Root of 0.9 into root of 1, 6. So, we can also write that as 0.9 into 1.6. So, that is going to be, when you multiply this one, so that is going to be 6, because 16 nines is 144. So 144 means how many, this one decimals 1 and this 2. So you will write here 1.44. So 1.44 is nothing but 12 12s are. So that will be 1.2 into 1.2. So you are going to take it only once. The answer is going to be 1.2. So the B option. So now here we can do it over here itself. So this is going to be together because this is not a perfect square. So now this can be simplified as, here it should go with HCF. You have to find the HCF of it. So here, now let us see for HCF what HCF we get here. 1 to 8, and this one can be also written as 1 to 8 divided by 4. 4 3s are 12 and 4 2s are 8. So HCF is 30. If we are doing with 32, now let us see this 288 goes with 32 or not. So this is going with 32. So the direct way, if we are doing it, 288 by 32. So 32 nines are, should be 288, and this also goes with 32. So HCF is 32 over here. You can check how it is, because I'm short of space over here, so I'm doing it directly. This should go with 32. The HCF is 32. So I have shown you the previous problems, how to find out the HCF. So now this is going to be 9, and this is going to be in the root, sorry, and this is going to be 9, and here 4. So this is going to be, now this will be root of 9 divided by root of 4. So this is going to be 3 by 2. So the option is C1. Now this I can also write this as, the mixed fraction means you are going to multiply 4 into this will be 8. 8 plus 1 is going to be 9. So root of 9 over 4. So this can be also written as root of 9 over root of 4. So this will be root of 9 is 3, and this is going to be root of 4 is 2. So now this I can write, because it is in the improper one. So I can write it here. This will be 3 divided by that will be 1 integer 1 by 2. So the correct option is 1 integer 1 by 2. So now let us look for the next one. Which of the following is the square of an even number? So even number, so now even number, the square of an even number. Can you see these? All the numbers are this is the even number because the last digit is 6. Here we can see 1, 5 and 9. These are the odd numbers. So the option is going to be 196. Which of the following is the square of an odd number? So now again, now here we are going to see the odd numbers. So here you can see the ending here is 6, 4, 9 and 0. So these are all the even numbers. So 9 is only the odd number. So the option is going to be 1369. So by this one we have completed today's work. Do like and subscribe to my channel so you get the notification of the other parts. Thank you.